Hello and welcome to CENOS training course Lesson 1, CENOS Workflow Overview. In this lesson we will learn about the general simulation workflow and understand the differences between different simulation setups. Simulation in CENOS consists of three parts: geometry, physics, and results. This division represents the actual workflow of the simulation. First you define the geometry of your induction heating system. Then you define physics, such as power, frequency, and materials, and once the case is calculated, you get the results. You can create your geometry in three ways: template, from CAD, and the advanced geometry editor. Template is the easiest of all geometry creation approaches. You just need to select from predefined templates, enter the geometrical parameters, and CENOS will generate your geometry automatically. This approach is good for billet and pipe geometries and applications such as preheating and scanning heating. The limitation with this approach is that you cannot simulate any other geometry rather than the ones offered by the templates. The second way to create geometry is by using from CAD approach. It was specifically designed to be used with CAD files. You just create the CAD of your system in any other CAD design software, import it in CENOS using from CAD approach, and define a simulation using your CAD as a base. You can import one or multiple CAD files, which makes it easy to use, but you cannot define any type of movement in from CAD, which means that it can be only used for static heating calculations. Advanced Geometry Editor is the last and most flexible way to create your geometry, as you don't have any limitations on geometry, movement, or application. With this approach, you can modify and optimize your simulation in any way you want, but it requires additional knowledge on how to operate Advanced Geometry Editor, as these modifications you need to make manually. Once the geometry is set, you can choose from three types of analysis: thermal, electromagnetic, or coupled induction heating. Thermal analysis is useful for completely thermal calculations, such as heatsink or heating in oven applications. Electromagnetics helps to evaluate only the electromagnetic aspect of the system and is useful for inductor design iterations or, for example, busbar simulations. Induction heating combines previously mentioned thermal analysis with electromagnetics and is capable to carry out full induction heating simulation. This physics option can be used for virtually any induction heating application. Once the simulation is set and calculated, results will be automatically opened. CENOS results consists of two parts: visual and energetical data. In visual results, you can see things like temperature distribution, hardening profile, or magnetic field. In energetical data, you can find out power consumption and see values such as inductor resistivity, inductivity, and other parameters which are helpful for inductor in-depth analysis. As you can see, there are multiple ways for geometry creation and physical analysis, and you can combine any one of them to carry out any kind of simulation you want. This is the end of the first lesson, which was about CENOS Workflow Overview. Thanks for watching.